Hi guys, welcome back. So let's start today with a little bit of an extremely scientific question here. If we were to observe this scenario happening, oh, lovely day. Definitely ended up on YouTube for a reason here. Happy puppy on a swing. But here's a very scientific question for you. Is the dog ever going to stop the motion of the swing? Well, right now his owner is giving him a pretty consistent push and it turns out that he's loving it. But if his owner were to stop pushing him, lending him a hand, will the swing ever stop going back and forth for the dog? Well, if this has ever happened to you, if you've ever been having someone push you on a swing, then you already know the answer to this. Yes, if someone stops giving you a push on the swing and you don't do anything else with your own energy to keep the swing in motion, eventually the swing will stop. This is something that we call the law of conservation of energy. And we've already talked about this year when we were talking about ecology and how organisms have to consistently eat in order to get the energy, because as you receive energy, the energy doesn't always stay with you. It is transformed into different types of energy. So the law of conservation of energy is this: energy is not created or destroyed, but it does change forms. So you receive energy in one form, your body changes it to another, and you release the energy in an entirely different form. It works the same way in nature. So now, let me ask you this. If you've ever seen one of these Newton's cradles here, take a look at this. If you've ever played with this and you go ahead and you lift one end of the Newton's cradle, will it ever stop? Well, yes. In this example, energy is being transformed. It begins by having to provide energy to the first object in line, then that energy has to transfer into the other objects, creating motion. But eventually, this energy will stop. Does the energy disappear? No, but the energy is transferred to other form. Okay, so let's apply that idea to something called a pendulum. If you have never seen a pendulum, it's a very simple tool. We have a weight hanging from a single fixed point. So on my pendulum here, click reset, I want to give my pendulum the energy that it needs in order to make it all the way to the other end of the pendulum. But in order to give it the energy to move through a complete swing on its bracket, I have to give it the ability, the potential to do work. This is one of our examples of potential energy. And a great way of giving an object the ability to do work is by putting it up at a height. We call this gravitational potential energy. Okay, so before we give the pendulum a swing, there is something really important I'd like you to notice. At the top of our pendulum, I have two energy readers here. One says PE, that stands for potential energy, and the other says KE, kinetic energy. Now, our energy is measured in a unit called joules. So currently, with my pendulum up at the highest fixed point in the swing, I have a total of 16 joules of potential energy. And if you look at the scale, that is 100% of the energy available. Now, if I let my pendulum swing, I want you to watch what happens to the potential and the kinetic energy. So giving it a swing, and I'm going to pause this halfway through. Now, in that distance, from the height of the pendulum down to the base of the swing, I saw my energy transform or make a shift from 16 joules of potential energy to a complete turnaround to 16 joules of kinetic energy. Well, how in the world did that energy change from potential to kinetic? When I had my pendulum up at this height, there is that brief moment where the pendulum is at rest, even if the object is not being held. Put yourself back into the mindset of being on a swing set. When you're at the highest point in your swing, there's a moment where you almost get some hang time in the air. It's a brief nanosecond of pause before gravity gets a hold of you and pulls you back down towards the ground. In that brief second, when you're up at your maximum height, you have 100% potential energy. But as your swing starts to go back down, now you have to use that potential energy that you stored in order to gain motion. So we are losing potential energy as we pick up speed, and I'm gaining kinetic energy until I get to the bottom of my swing path. And now look at the energy I have. Now I have a full 16 joules of kinetic energy. I have switched all of my stored potential energy. I've used up everything in my bank account to give me the highest rate of motion by the bottom of my swing. Okay, so now I'm still paused at the bottom of my swing path, and I need my pendulum to make it up the other side of the track. But in this case, is it going to require more work to go up the other side? Absolutely. Would you rather run uphill or run downhill? Well, running uphill means more work. So all of that kinetic energy that I just gained to get to the bottom of my swing path, now, again, I have to spend that energy. I have to use my kinetic energy to make it up the other side of this hill, fighting some gravity here, to make it back up to the other point of my swing. So once again, as I push swing, I want you to watch the kinetic and potential energies. So here we go. As I'm making my way up the other side of my hill, oh, check that out, and pause. I had to use my kinetic energy. It is transforming back into potential energy. Why am I getting potential energy? Because once again, I have put my pendulum up at the highest height that it can hit in this track, which means it's going to have 100% of the potential to swing back down. Take a look at my energy meter here. Back at the other point of the track, 16 joules of potential energy. All that energy has been transformed to a stored form of energy, gravitational potential energy. And then as I let it swing, I see a transformation again. So every single system is a consistent shift between stored energy and potential. Do I have enough energy to do the work? Put that energy into motion with kinetic energy, and then back to stored potential, kinetic, potential, kinetic. Now, with all of this, here is a really good place to pause. Look at my amount of energy. I no longer have my 16 joules of energy. I only have 15 joules of energy. Is the energy disappearing? Absolutely not. This is the law of conservation of energy. The energy is still completely here. But Mrs. Young, it doesn't say 16 joules anymore. No, it does not. Energy is being transformed out of this pendulum system. Think about those forms of energy. We had mechanical energy. Thermal energy is where a lot of energy likes to travel. And we know if we were to let this swing in the real world, you walk away for a minute and come back, and it might barely be moving. The energy didn't disappear, it simply transferred to other forms. There's a lot of friction happening here, and energy is moving into new locations, new forms. All right, so here's what we want to do now. On Google Classroom, you have an energy transformations document for the pendulum swing. This is the link to that digital pendulum that I was just using. And here's what I'd like for you to try. finding where the pendulum has its highest and lowest levels of potential and kinetic energy. So I'd like you to practice this idea with the law of conservation of energy, where we can find the different forms of energy and how energy is making that shift between potential and kinetic. So please stay looking at that suggested learning timeline. I know a lot of you have already started on the energy basics from Monday. And then please don't forget, on Tuesdays, Thursdays, and Fridays from 1 to 2 p.m., I will be doing Zoom links for a little reteach, homework help. Thanks, guys. Have a great rest of your day.